All right, continuing with lesson 4.2, linear functions, we're going to look at some examples to help you get started. All right, it says which of the functions are linear? Remember, linear means it represents a line, and it means it's x to the first power. Okay, so if we look at the first function, x squared, that's not to the first power, so we can say that the first one is not linear. Okay, and it's not linear because of that exponent that I just missed there. All right, g of x equals 3x plus 8. This one is linear because there's no exponent, so it's assumed to be 1. So this one is linear. And then we've got h of x equals 4. If you remember when we were going over some previous examples, this is the same as y equals. When you have y equals 4, that's a horizontal line, so that is linear. It just doesn't have a slope. So that one is linear. And explain your reasoning. It's a horizontal line. Okay? All right, moving on. Explain how to graph each linear function using the slope and y-intercept. All right, so f of x, again, this is in function notation. F of x is the same as y equals 2x minus 7. This is a linear equation, so we know it's going to represent a line. The slope is positive, so we know it's going to go up from left to right. And we know that the slope equals rise over run. So since the slope is rise over run, we know that the slope is 2 over 1. We also know that the y-intercept is 7, and that's where we start. Okay, so if we look at this, we're going to go down to -7. There's -5, 6, 7. So the first point we put on the graph is the y-intercept. Okay, so that comes straight from the equation. And then we are going to rise 2 and run 1. So we're going to rise 2, run 1. And you can do that as many times as you like. All right, so then all you have to do is graph your line. And that's how you graph a linear equation. All right, the second one, f of x equals -2/5 x plus 1. This one's already in the form rise over run because it's already a fraction. We know it's going to go down from left to right because the slope is negative, which tells us it's going down. And we know that the y-intercept is +1. So if we put a point at the y-intercept, and then we use the slope to go down 2. So you go down 2 and run 5. All right, you also could go +2 and then -5. Anytime you have a negative fraction, one of the numbers will be a negative direction and the other one will be positive. Remember, when dividing, you have one negative means one of the two will be negative and the other positive. All right, so to graph this line again, we're going to go through those points. See if I can line it up just a little bit. I can't get it lined up exactly, but that's pretty close. All right, so this question says, suppose you are in a building at 28 feet above ground level and you take an escalator down to ground level. On the escalator, your distance above ground level changes by -2 feet per second. Write a linear function to describe the distance, d, that you are from the ground level over time, t. All right, a couple of things that we need to look at, distance and time. Okay, so we know that we start at 28 feet above the ground level, and we know that we change 2 feet per second. So the first thing we need to do is, what are we going to name our function? Since our variables are d and t, we have to know which one is our independent variable and which one is our dependent variable. So we know that it's going to depend on, like, time is our independent, okay, this is like our x value, and d would be our dependent. The distance traveled depends on how much time goes by, okay? So the first thing we need to do is write that as d of t. All right, so d of t is our function. It's in function notation, and we know that we're going to start at 28 feet above the ground. And then we're going to drop 2 feet per second, so minus 2 feet and seconds in time. All right, so this is our linear equation. If you want to rewrite it, you can write it with the slope first, negative 2t, and then the y-intercept would be 28. Both of these are correct. This is kind of the format we stick to most often, but this also represents the same equation. All right, so it says write a linear function, and we did that. So we have answered that question. State the domain and range for each function graphed. All right, so we want to state the domain and range. So the domain is all of your x values. So the domain and the range can be written in set notation. It's a very poor set symbol. Apologize. Let's see if I can do a little bit better. That's some better. All right, so the domain we know comes from our x's. All right, so we're going to put our x's here. And we know that it's going to start at -1 because it looks like that's the furthest we go on our x-axis. And the line goes all the way over to 3. So from -1 to 3. And we know that x is going to be in between the -1 and 3. Now the solid circles means that those points are included. So that's why I have the less than or equal to symbol to show that those points are included. All right, so that is our domain. So that just shows how far it goes on the x's. All right, so our range comes from our y value. So we're going to put y here because it comes from the vertical axis. All right, so this is this blue line here. So it goes down as low as -5, and it goes as high as +3. So we're always going to start with the negative number first. So we're going to put -5 on the left, and we're going to put 3 on the other side. And again, because of those solid endpoints, it is less than or equal to. So these are always have to be in the same direction. But again, your domain comes from your x and your y values. All right, this one, we're going to look at domain and range. All right, so our domain, again, is going to be our x values. Our range is going to be our y values. So the domain is our x's. It looks like if we go over to, looks like about -3, and that one's at 4. So we're going to go from -3 to 4. Again, these endpoints are solid, so we're going to close those. If those were open circle, it would just be less than, not less than or equal to. All right, and the range goes from the lowest point. So it looks like that's 2. So it looks like the lowest point is about 1 to 8. So from 1 to 8. And again, the endpoints are included. All right, the next example, you make an investment in a plan that will pay simple interest. The table indicates the value of the investment as time goes on. Year 0 is the year that you made the investment. All right, what does the value at year 0 represent if this linear function is graphed? All right, year 0 represents the year you made the investment. So what we want to do is talk about 0 and a number, so that means that would be your y-intercept. So 0 and 2000 would be your y-intercept. So if we graph 0, 2000, be right there, and this would be the y-intercept. All right, what would the difference between any two consecutive values of investment determine? Two consecutive values, if we look at this point, and we look at this point, and we're looking at the change in those, remember that would be our slope. We use slope formula to determine the change in y's over the change in x's. All right, write a linear function, v of t, for this information. All right, so the value of the investment over a certain amount of time, okay, the years of time. So v of t equals, and then we have an initial investment of 2,000. And then it's going to increase, you can tell, by $100 each year. So plus $100 t over time. All right, it says what is v of t? What does this value represent? V of 10 represents year 10. How much money they have after 10 years. So you can plug in v of 10, and so you can plug in 2,000 plus 100, and then put in 10 there. And then when you multiply that out, that'll give you how much money they have in 10 years. So 10 times 100 is 1,000, plus 2,000 is $3,000. So after 10 years, their investment has $3,000. All right, then it says to graph the function. All right, I put a graph on here. We've already graphed the first point. So we're going to graph the next point, 1 and 2100. So 1 and then 2 and 2200. 3, 2300. See, I think the 4 is supposed to be right there. Can't tell where my points are. And 5 and 2500 is right there. So if I graph my points in the correct place, you can see that that would create a linear equation. All right. Last examples, determine the slope of a linear function from the given table of values. If possible, write the linear function in slope-intercept form. All right, so the first thing you have to do is determine the slope. So let's look at a couple of these. So the slope would be change in y's over change in x's. So slope, we're going to do 11 minus 14, negative 2, minus negative 3 makes that a plus 3. Ilm equals negative 3 over 1. So our slope is negative 3. So we're going to have y equals negative 3x. And we know that the y-intercept is the number with the 0 for x. So negative 3x plus 5. So this would be a linear equation. All we had to do was find the slope, and the y-intercept was in the equation here. All right, so for 21, this may be the last one we get. We've got slope equals 9 minus 9 and 2 minus 3. So slope equals 0 over negative 1. A slope of 0, that means there's no slope. So that means we've got y equals whatever our y-intercept is, which is 9. All right, if you have any questions,